Sonal, you can start at 7.
Okay, sir.
Mithun sir, welcome.
So should we begin?
Please.
Good evening, everyone. Hope you had a good day. As rightly said by someone, machine learning is the last invention that humanity will ever need to make, and artificial intelligence is the new electricity. It has actually proven to be a greatest part of our lives as the potential benefits of the same are huge. So, as you all know, we are gathered here for an advanced masterclass on application of artificial intelligence, machine learning, and deep learning in domestic and international business with special reference to education sector. We have witnessed amazing sessions by our esteemed guest in the past few days. So welcome you all to the sixth day of our program. Let's make this session an interactive one. Shukla sir, over to you now.
Yeah, well said, Sonal. Yeah, so that's the deep learning and the machine learning is changing the lives. Okay, so I welcome everyone on this sixth day of online session, and it will be followed by the physical sessions from Monday onwards. So I think you all are aware of that. So the venue details I'll be sharing it. It is in Bharati Vidyapeeth. That is, we are having so many campuses, but this is at Irandvane campus. So whenever you'll ask for Bharati Vidyapeeth Irandvane campus, you will reach to IMED, that is Institute of Management and Entrepreneurship Development. So I will be sharing the same with the mail. I'll be also sharing the map also. So on Monday we'll be beginning with the let's say 9:30 we want to start. So we'll be assembling here. We'll have some tea and some snacks, and then after that 9:30 would like to inaugurate in physical mode. So in case of any difficulty, like you can contact me, or so that I can help you in case if it is some kind of a problem you're facing with that. But try to make it success by with your physical presence. Now coming to this day 6, so I will just like yesterday what we have seen is that was really amazing, that in the neural network, so it was just working like a human mind. So like we are having so many options, so in this we have been given so many weightage, and by changing the weightage to every factor or every dependent or independent variables, we can change the results, and we can match the result whatever we want. So that, so it was a really amazing, but only thing that we had bit less time yesterday, so we can see some more models in this. And also we have also seen the activation function of that is a TANH, that is model, and also the RELU. So and then after that, then today whatever is we are having is there is a one silhouette index. Okay, so maybe we'll be going through that, and also the principal component analysis. Some part I think we have seen yesterday, and also we'll have more focus on today also. So I welcome Mithun sir. Mithun sir, you are there here, or shall I invite some of the reflections? Okay, before.
I'm here, sir. I'm here.
Yeah,
You
yeah,
can,
yeah.
but you're welcome to sort of take the participants' feedback.
Yeah, 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 please. So now I'll invite Mithun sir to please take over and please go ahead. And the participants are welcome to give their feedback.
Okay, thank you very much, sir.
Yes, yes, sir.
Before I speak, I think any of the participants can sort of, give a general feedback of what happened yesterday, and in general, 5 days what we covered, a high-level summary, a perspective. We can definitely sort of discuss some of these points. Anybody can speak up. If you don't speak up, we have to call out your names.
Yes, yes. I think Ravin sir will come. Yeah, yeah. Mithun said today at 9 o'clock. There is one Guruji, so he will be joining to give us blessing. So he will just tell some activity for half an hour. So like yesterday, somebody has come. So we have at 9
Yesterday,
p.m.
yesterday after 9 o'clock, which session was conducted, sir?
No, there was a smart the short session. There was a of half an hour.
Okay,
So that it was a general. He spoke about the AI and machine learning. So today we had one Guruji
okay,
from.
okay.
It is a part of from the ICT that we should keep some sessions from the different areas. So just I'm trying to cover up in this small time whatever is there. Yes,
Definitely,
sir.
sir. Sure.
Yes, sir. Yes, sir. Rabin sir, would you like to say something at this end?
Yes, 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 sir. No, no problem, sir. Yesterday started with the neural network. Uh, Mithun sir just introduced this neural network, especially deep neural network, which are used for non-linear data analysis. Uh, exactly. Actually, to be frank, I thought of reading more on deep learning, but yesterday session with the explanation from Mithun sir had given little, in-depth introduction part to the study, especially the taking example of buckets as well as filling the task with hidden as well as the final output nodes. Eventually, the theoretical part with how to give the weights and how to gather the weights and weights by taking the information from input values. So transfer functions, it makes up the formulation there and transfer to activation function by which you will get the output. With that example of a color basket, so definitely it directly taken a seat in our brain, so that whenever you start working with the codes, definitely it will help us lot. That was what I can convey in a short time without taking much time.
Good, sir. Good. Yeah, Dr. Rabin sir is. So anyone else would like to share?
Thank you so much for your feedback, sir.
Thank you, Mithun sir.
Okay, guys, you need to speak up. This is the
Uh,
last day. You have to speak up. Yes, please.
yes, yes. I think yes, Dr. Ankush can share something. Ankush sir, yeah. Or anyone else like okay who wants to share. Mithun sir, it seems the people are in the weekend mode, so we are just yes forcing them to be here. Yes.
So we'll also take a holiday and go, sir.
After 9:30 we'll go, sir. Yes, sir. Correct, correct.
We don't have the option to.
Yes,
Okay.
yes, yes, sir.
Okay, guys. I'll start off with something else today, guys. I'll take off. Let's not spend too much time on this. So today, what I'll be talking about is another very, very interesting subject, guys, which is, I hope you can see my screen.
Yes, we can see.
Okay, this is what is called as a recommendation engine, right? This is called as a recommendation engine. Recommendation engine and such things are becoming very, very popular in today's connected world. So where is this used? Let me tell you, because there is there are algorithms. Don't worry too much about the algorithms. Always ask yourself, what does this algorithm do to solve my problem? How is this used? Where is it used? What are the insights that I can draw? That is a prime concern to us, more than learning. More than learning about any algorithm and such things, where can I use it? What are the pitfalls? What are the problems with this algorithm? How do I sort of benefit out of this? That's the question. Now, one very, very popular in today's world, right? 3 4 years back, in fact for last 7 years it's been around, but last 3 or 4 years, especially after COVID, this algorithm has become very, very important. This is called as recommendation engine. Now in day 3 or day 4, I was just speaking about a priori, works similar to it. But here, certain important concepts I'd like to emphasize, and I'll also maybe share the code. Let's look at the agenda here. What am I going to cover? Background about recommendation engine. What are the challenges of recommendation engine? What are the different types of recommendation engine? What is the ideal data that you need to have for recommendation engine? And what is the expected output that you can get? These are the 5 points that I would like to cover. Firstly, let's talk about recommendation engine, right? When we speak about recommendation engine, please picturize Amazon or Flipkart or Jabong or Snapdeal or Mintra, any of these e-commerce platforms. That's what you should think of, right? Now, we are living in a very connected world. I repeat, we are living in a very, very connected world. Now, in this kind of a connected world, especially in an e-commerce space, right, there are millions and millions of items. When you go to Amazon, Flipkart, you can see millions and millions of products. The question is, which one should they recommend? Now, you may the products could be ranging from books, it could be apparels, it could be songs, or it could be movies, it could be anything. E-commerce business, many of these e-commerce businesses, they survive upon recommendation. Now, we are not saying that all recommendations should be appropriate. Recommendations basically maybe barely 1 or 3% may be the accuracy, which means if I make a recommendation to 100 people, 1 or 2 people may decide to buy it. 1 or 2 people may decide to buy, right? But not making a recommendation is not an option, because if you don't make any recommendation, nobody will buy anything. So fundamentally, what we are looking at is, in a typical e-commerce, I repeat again, I'm talking about e-commerce website basically, we have what is called as a long tail problem. This is called as a long tail problem, wherein you have thousands and thousands of products. The customer will go really mad looking at the number of products. So many books are there. Which one should I buy? What is What suits my interest, I do not know, right? There may be a very good book, murder mystery book, but I do not even know that this product exists. And the customer perhaps cannot show all the books related to all the products related to one particular domain. This is a big problem. So this is where we say the connected world in e-commerce, long tail problem exists. Long tail problem basically means millions and millions of products are there. Then it becomes a bit difficult to recommend. Which one will you recommend out of these 1 million products or 1 million movie songs? Correct. And you, as you have to think from the point of view of a businessman, because if you don't make any recommendation, he'll not buy anything. So it's a loss to you more than him. And Amazon, Flipkart, movie ticket. When you're talking about buying movie tickets, buying bat or shirt or Bluetooth speaker, the idea of recommendation comes into picture. So long tail problem is one main problem that you encounter, because when you have so many products, it's not very easy to recommend. So when we speak about recommendation engine at a very high level, there are three different types. One is what is called as content-based filtering. Second one is what is called as collaborative filtering. And the third one is what is called as hybrid filtering. Now let's look at collaborative filtering. Collaborative filtering is further divided into model-based collaborative filtering and memory-based collaborative filtering. So when I'm trying to make a recommendation, this is not, there's again not, hi-fi mathematics and such things that we're talking about. We are talking about very simplistic, commonsensical approach, what is called as item-based collaborative filtering and user-based collaborative filtering. So recommendation engine, mostly one popular technique called as collaborative filtering is used. Within that, you can break it down into item-based and user-based collaborative filtering. What is this item-based collaborative filtering and user-based collaborative filtering? When you say item-based collaborative filtering, look at the similarity between the items. And if two items are very similar to each other, then basically you can recommend people who buy one particular item to another particular one particular item. If a person has bought, maybe you can recommend another item which is very similar to that first item. You can recommend to the first person, right? For example, you can think of a person, if he is a big fan of Agatha Christie's novels. Now, you know that in the past he has purchased one particular murder mystery novel. You can cross-recommend another book to him, which is again a murder mystery novel. So that's why you see in YouTube, people who saw this video, if you look at these videos and such things, people who saw this also saw another video, also watched another video. People who bought this also bought this. How is the algorithm able to, how are they displaying it? Because they would have studied your past purchases and your behavior in YouTube or any of these spaces. And based on your past activity, they're making a recommendation. So this is what is happening in a recommendation engine. Item-based collaborative filtering looks at the similarity between items, and user-based collaborative filtering looks at the similarity between users. So for example, I'm just giving an example. Let us say I'm just giving an example. Let's say I and Shukla sir, we have gone to the same school, same college, and therefore there's a high degree of similarity between him and me. I'm just giving an example, right? So there's 90% of similarity between him and me. By and large, let's say our age is the same. There's not a huge gap between our ages. So what you can do is you can look at all the items that Shukla sir has bought and all the items that I have bought. Those items which I have not purchased, but he has purchased, you can cross recommend those items to me. And those items which I have purchased, but he has not purchased, you can cross recommend those items to him, right? Which basically means that if he has bought item A, B, C, and not D and E, you can recommend those particular items to him, provided the similarity between the people are very high. If there is a lot of dissimilarity between me and Shukla sir, then obviously those items which I have sort of purchased, you can't sort of recommend to him. So this is at a very high level. It works mainly in recommendation engine and such things. Now, let's just go forward. Now you can look at user-based and user profile update. So there are different kinds of data, streaming services. You can have which all movies that the user has watched, other user ratings. We are talking typically in terms of books, movies, and such things. And what is the kind of rating that the user has given? That is one part. You can use different recommendation techniques like text mining, KNN, clustering, matrix factorization or neural network as recommendation techniques. But for a recommendation model, you have to use either a collaborative filtering or hybrid system or neural network. Now, what this does is basically it recommends from it recommends item lists from each application field. Item list basically means that from among these 5 items which you can recommend, from among these 10 items which is that you can, what is it that you can recommend. So that is at a very high level what is happening within the recommendation engine. Let me just skip this and this as well. Now, there are main challenges in a recommendation engine. One is long tail problem because you have millions and millions of products. That's when it becomes difficult to recommend. And these millions and millions of products which you are talking about, not all items are touchable. I can't touch all the items. Therefore, I can't maybe there may be a very good. Many times we buy some the item looks very beautiful when you see the preview, but when you get the same item delivered, it is not at all that good, right? Let's say there's a beautiful saree, you looks very gorgeous. When you look at this saree, but when the saree you order it, when you get it home, it looks, oh my god, this is so tasteless. It is very unpleasant. It is not so appealing at all, right? So what happens is that basically there are so many items which the customer cannot see. I cannot see millions of products. If I'm a customer, I can't see millions of products. I can't touch all the items. If I can't touch the items, I do not know the texture. I cannot feel it. So when you have so many items, when the customer cannot see all the items, he cannot touch all the items, how do you make a recommendation, right? In a brick and mortar world, in a small kirana shop or something, in the good old days, you have maybe, if you walk into a store, maybe there are 20, 25 items, and he looks at a person walk in, the customer, and then he may make a recommendation because the items are very few. There are barely 15, 20 items. You can make a recommendation. Typically, the person there, the shopkeeper basically looks at your face and he says, okay, if there are 2 kids, maybe he may recommend comic books or he may recommend a bat or a ball, right, to the person, saying that you may buy it. So that he can use his brain or common sense. If you're a youngster, or if you're a college student, maybe he may recommend, people are very fond of, let's say, bangles and other decorative items and such things. You can recommend this to a college going girl. Now, if you are slightly more, older, you may recommend books and such things. That is purely based on experience that you're doing it when you have 15, 20 items. Now, we are here talking about a situation wherein you have millions and millions of items. When you have millions and millions of items, it becomes very difficult to recommend. So that is the problem. So that is typically called as long tail problem. And second problem here is what is called as cold start problem. Cold start means what? Cold start means, uh, you know, let us say the customer has come for the very first time into Amazon. I do not know his past at all. If I do not know his past purchases, his likes and dislikes, what will I recommend? I can't recommend anything at all because this is the first time I'm seeing. I do not know what he likes, what are his dislikes. And if I make a generic recommendation saying that, okay, sir, you buy a Bluetooth speaker or you buy a book. No, he may not be so inquisitive. He may not be so curious about reading books and such things. That's not his cup of tea at all. Why would you want to recommend a book to a person who does not read books? Right? But remember the golden rule that if I don't make a recommendation to a person, I will lose him as a customer. If I make some kind of a recommendation and he says that this recommendation is apt, this recommendation is good, there is some chance of him buying. But if I don't make any recommendation, there is no chance of him buying this product. So here, cold start problem means basically a fresh customer does not have any data. I don't have any data at all. What will I recommend? This is what is called as visitor cold start or user cold start problem. Second one is what is called as item cold start problem. Item cold start means basically, let's say Apple has launched a fresh product. There are no consumer reviews, there are no customer reviews because nobody has used it. This is the first time we are seeing the product. So if the product itself is new, to what kind of customers, to what is the target audience, to whom will I recommend? That's again a problem. Third kind of cold start problem is what is called as system cold start, user cold start, product cold start, and system cold start. System cold start basically means that the system of recommendation engine. Let's say I'm starting a new e-commerce space. First time basically I've launched this, and users are new, basically products are new. I do not know the profile, I do not know the similarity between the items. I do not have a proper recommendation engine. So what will you recommend? That's a question. Yeah. This is called as cold start problem. And lastly, what you have is what is called as data sparsity issues. Data sparsity means, see, almost all machine learning models and AI models rely on data. If you have rich data, you'll get better results. Now, but in a real-time scenario, you may not get rich data, right? In a typical e-commerce site, imagine what kind of data will you have? You will not have much data at all. Why do I say that? See, when you are doing this Boston housing data set, you had rich data, 15, 20 variables you had. When you did telecom, you had around 29 or 30 variables. You have some kind of a rich data there, and therefore you could go ahead and do some analysis because you have data. Almost all machine learning models rely on data. Though in an e-commerce website, and we are living in a day and age when people are not very comfortable sharing their data. I will not go to Amazon and give all my data and such things. Well, what is the guarantee that it is safe? I can't trace it, right? So barely I may know his name. That name also may not be clearly specified as Ravi Kumar or Shashikala, right? People use false names. The big guy they type, or the big medallion, or Isro princess, something like that they'll type. The big guy, it's very difficult to find out his gender also many times. Date of birth and such things may be fake. When you have limited data or sparse data, it becomes even more challenging to make a recommendation. If you have a lot of data, you can use all these analysis. But when I don't have any data at all, what recommendation will I make? So these are all certain challenges that are present in the in the system itself, right? Not so easy to make any recommendation. So when you look at the type of recommendation engine, there are two types. One is what is called as prediction-based recommendation engine. Second one is called as it is not really prediction. It is just a recommendation, right? Prediction-based recommendation does what? Given that you have a history of purchasing books, what is the probability that you'll buy a particular book? So it is prediction. It is trying to predict. Of buying, based on your history, what is the probability that you'll buy umbrella, or what is the probability that you'll buy a book, or what is the probability that you'll buy a furniture item, something like that. A recommendation just gives a set of recommendation. It recommends a set of items, 1, 2, 3, 4, 5. These are the items. So these are the two types of recommendation engine. So look at this. So typically, what should the data be? User item rating metrics. So in the row, you have different users, and in the columns, you have different items. So based on this, we'll push this into a collaborative filtering model. Once you push this into a collaborative filtering, you can either get a prediction out of it, saying that it predicts on item 2 for an active user, it predicts an item. Secondly, it can make a recommendation saying that these are the top 5 or 6 items that a customer will buy. So these are the two things that are possible. For example, if you look at this, you have a set of users, and these are the movies. It could be a set of movies like The Godfather, or any of these other movies. So these are the rating. This is the rating that a person has given. 10 means maximum. He likes this movie Godfather. -1 and basically means that he is not given a high rating to this. So you need to feed this data, user item rating metrics. If you have this data, recommendation engine becomes easier for you to execute. Okay, so here the data is slightly challenging because you can have either implicit rating or explicit rating. What is the meaning of implicit rating and explicit rating? Explicit means basically a person has explicitly rated a movie. I have gone to Movie Lens and I have watched the movie Sholay, and therefore I'm giving it a high rating. I have not liked the movie Shamshera, so I'm giving a poor rating. I do not like the movie Brahmastra, so I'm giving a poor rating. Let's say there's a movie Kashmir Files, I'm giving it a very good rating because I like it, right? So I have gone and I have rated the movie because I liked it explicitly. Many times you might not have explicitly rated the movie. You might have given what is called as implicit rating. What is this implicit rating? Implicit rating basically means that there are certain items and such things. Now, within these items, there may be n number of items. Let's say you go to Hindu, you read Times of India or Hindu or any of these newspaper online, and out of 1 hour that you read, out of 1 hour for 45 minutes, let's say you have read only sports. 45 minutes you're reading only sports. Next 10 minutes, let's say you have read about stocks, share bazaar, and you looked at gold prices and such things. 5 minutes you may spend looking at movies and such things. So this is a case of implicit rating, wherein you have not rated anything explicitly. But I know out of 60 minutes, 45 minutes you have spent on, let's say sports and such things, which means that you must be a sports buff. 45 minutes, why would you spend reading about Rohit Sharma, Virat Kohli, what is happening in the world of football, what is happening in the world of whether Manchester United beat Barcelona or not? You're obsessed with sports, and therefore you're spending 45 minutes on sports. 10 minutes, maybe you're interested in gold prices going up or down, silver prices, these things. So next interesting item for you would be this, because you have spent a lot of time there. And 5 minutes maybe you spend on movies. So I don't consider yourself as a movie buff. So if I have to recommend something to you, I would rather recommend something to you in the field of sports. In the field of sports, right? Instead of something else. So this is what is called as implicit rating. So this is how the data should be when you are, you know, looking to build a model. So collaborative filtering is the kind of model. So here you have user-based collaborative filtering and item-based collaborative filtering. So it's useful for movies, books, and such things. Then it is useful. It requires explicit ratings. Correct. Second is basically UBCF, user-based collaborative filtering. Here, you will have user cold start problem mainly. User-based collaborative filtering, right? So it depends upon the user rating. So the fresh user, if there is a fresh user, what will I recommend? Because I do not know anything about it. Data sparsity may be there. Because why do I say data sparsity? If there are if there are 10,000 products, I as a customer may give a rating for, if there are 10,000 movies, I may not have seen 10,000 movies. I may have seen 25 movies in my whole life. So I will give a rating to only those 25 movies. So 10,000 minus 25 is 9,975 movies. It will go as unrated movies because I have not given a rating because I have not seen those movies. In the data, it will appear as blank. In the data, it will appear as blank. So against one person, there will be 9,975 missing cases. Now, there may be a second person. Out of 10,000 movies, he might have seen, let's say, 100 movies. So in his case, 9,950 movies will be blank cases. So these are all problems of sparsity. That is sparsity problem. So here, item cold start. Here, if there is a new item which is being launched, you can't basically give a rating to it, right? Because it's the first time you're launching. So what are the advantages of IBCF model? Item-based collaborative filtering. Item-based collaborative, automatically there is no user cold start here. It calculates the similarity between items in a more stable than similarity between users. So why do we say similarity between items is more stable than similarity between users? Simply because, see, let us say I have I have given a rating. I have gone to office. I've come back. There are floods in Bangalore. My boss has been very, very, rude, mean to me. I do not like my boss's face. His attitude is disgusting. He always abuses me. He puts me down. He insults me. He humiliates me. And in Bangalore traffic, 1.5 hours, 2 hours, I have to drive. And then you're asking. Then if somebody comes and says, "Give me a rating," obviously I'll give a poor rating because I don't like what is being. I have had a terrible day. So what I'm trying to say is basically the user's mindset, whether you're in a good mood or a bad mood, that will also influence what rating you give. If I'm in a happy mood, I'll give a better rating, right? Sunday morning, you come and ask me, I'm in a good mood because it's a holiday time. Are you able to hear me, everybody? Are you able to hear and understand?
Yes, sir.
Okay. So I'm just saying that user rating, basically, I was just talking about user rating. So how users rate, it's a very subjective thing. yeah, at late in the day after in the end, the late in the day after office hours, if you ask a person, he may be in a terrible mood because of the developments of the day. So poor rating will be given. Correct. So based on his poor rating, if you're finding out whether he is liking a movie or a book, it may not be advisable. On the other hand, if you're looking at item similarity and such things, it is likely to be more stable because there's you are not driven. Their subjectivity is reduced. Basically, subjectivity is reduced because people are not rating based on their mood, based on their experience in the day. So these are certain advantages of IBCF, item based collaborative filtering. So just take a look at this similarity measure. Let me just open up an Excel sheet and tell you how this works. It's a very simple, commonsensical approach. There is no hi-fi mathematics that, like in the case of linear regression and all, it is mathematically rigorous. In the case of neural network, yes, there is a bit of mathematics. I'm not denying that. Partial derivatives, that, this and all, but I think it is still manageable, right? Let me just give you tell you how it works basically, right? There is nothing great about this, but just to draw your attention. Now you can see here, this is similarity matrix. You have along the row, you have 5 people. Let me just cook up some name here. Let's say name. When I say name here, I have John's name. I don't know. I'll let know what I'll say. Samuel. I will say Kiran. Then I'll say Pankaj, and then I'll say Anju, and then I'll say Ram, right? These are the people who have given a rating. So what have they rated, sir? They have given a rating for product 1. Correct. So this is a pain. Look at this. There are 5 products. So let us say John has given a rating of 4 to the first product. On a scale of 1 to 5, he has given a rating of 4. Let me just copy this. He has not purchased product 2. He may have purchased product 3. He has given a rating of 5. Here for product 4, he has given a rating of 1. And product 5, he is not. He does not know. He has not purchased it at all. So it has gone unrated. When you look at Samuel, Samuel may have given a rating of 3. And this guy may have given a rating. He may have given a rating of 5 for product 2. And he has given a rating of 2 to product 3. The rest of the items he has not touched because he has not bought this product at all. This guy here, this girl here, Kiran, she has bought only product 3, so she is able to rate only 1. Pankaj here, he has given a rating of 1, 1, 1. He has not seen product 4, and he has given a rating for product 5 as 1, right? Then you have Anju, she may have given a rating of 4. This may be 4, that's it. Ram has given a rating of 1. This is 3, and this is 5. So this is basically the input data. Now, what I have to do is basically I have to look. See, you may have millions of people like this. You may have millions of people. For the sake of understanding, I've taken few individuals and I've taken only 5 products. The question is, what should I recommend? Right? A priori is also a recommendation engine, but a priori and such things we do not use in the e-commerce space. So you have user item recommendation. Now, how the algorithm thinks is basically, let's use what is called as Jacquard similarity, right? Very simple. Let us say I have to find out the similarity between 2 people. That is John. I have to find out what is the similarity of John and Samuel, whether they are similar or not similar, right? How do I find out these guys' similarity? Okay. So similarity is calculated using a simple formula, S intersection T divided by S union T. This is the formula. So it's a very simple formula, intersection divided by union. Intersection divided by union means what? Very simple, equals. Intersection means basically, look at this. When you look at John and Samuel, the first 2 customers, okay, right? Both of these guys have purchased product 1. Both of these guys have purchased product 1, correct? John has not purchased product 2, but Samuel has purchased product 2. But again, when you look at product 3, both of these guys have purchased product 3. One of them have purchased product 4. None of them have purchased product 5. So when you look at how it works here, basically, intersection means what are the common number of items. Uh, product 1 and product 2, product 3, sorry, my apologies, product 1 and product 3 have been purchased by both. So what you have to do is you have to just write equal to 2. Common items will be in the numerator. There have been 2 items which have been purchased by both of these guys. So since there are 2 items, so it is 2 divided by, now what are the union of items? Look at this, product 1, product 3. You have to just start counting. Product 1, product 3, and product 4 have been purchased by John. Now look at Samuel. He has purchased product 1. You can't include this because it is not unique. John has, you have already included it in John's purchase. So 3, and here Samuel is buying one unique product, which is product 2. This is the 4th item. 5th item, though Samuel has purchased product 3, you can ignore it because it is not it is not unique. It has already been counted. So totally you have 4 product that is being purchased, correct? So therefore it is 2 divided by 5. So the percentage of similarity is 50% similarity between John and Samuel. There is a 50% similarity, correct? Now similarly, what I have to do is basically I have to calculate what is the similarity between John, put a comma here, and Kiran. Intersection by union. Intersection is what, right? John has purchased, okay, here, let me use a different color. I will use a red, right? Okay, I can't use red because Kiran has not purchased that item at all, right? It's empty here. There is one common item that has been purchased by both of these people, and that is product 3. So only one, right? So here, the similarity between, so 1 in the numerator, okay? In the denominator, what should I take? Look at this. This is 1, 2, 3. There is nothing here. This I can't take because this has already been included, product 3. So here, when I'm calculating what is the similarity between John and Kiran, it is 1 divided by 3. When I, oh, sorry, I'm typing in the wrong place. So this is basically equal to 1 divided by 3. So you can see here, there is a 33% similarity between, John and Kiran. So we are trying to identify the similarity at the end of the day, nothing else. Okay, we are just trying to identify the similarity. So let me just complete this. This is the last example that I'll give. Similarly, if you have to compute the similarity between John and John Samuel, John Kiran, and John and Pankaj, right? Intersection by union. What are the common items that have been purchased? That is the question here. See, this guy is John, and this guy is John, Pankaj. I will now use a greenish color because this is the common item. Look at product 2. John has not purchased it. Pankaj has purchased it. Ignore it. Product 3. This is how it looks. Okay. Again, product 4 has been purchased by John. Pankaj has not purchased it. Product 5 has been purchased by Pankaj, but has not been purchased by John. So look at the number of green colored cells. There are 2 common items. So that will go in the common items will go in the numerator. What are the unique items? Look, count all the products. 1, 2, 3. I can't count this green cell because it has already been accounted for. I can count this product 2 because this is the 4th item. Green cell cannot be counted because I've already taken this into account. So 3 plus 1, 4, 4. This is a unique item. So this is the 5th item. Now you have equal to 2 divided by 5. So you have a 40% similarity between John and Pankaj. Like this, what you need to do is basically, just as you calculated for John and Samuel, John and Kiran, John and Pankaj, you have to exhaust all the members in the data set. If there are 10,000 people, find out the similarity of John with the remaining 999 people. Yeah, after that, you come to Samuel, find out the similarity of Samuel with all the remaining 998 people. Until you find out everybody's similarity with the rest of the group, this procedure will continue. Now, if you have to restrict yourself to just three examples, now 50%, 33%, and 40%, which means that maximum similarity is observed between John and Samuel, which means that since the similarity between John and Samuel is the highest, what you can do is the similarity between John and Samuel is the highest. What you can do is whatever Samuel has purchased, but John has not purchased, you can recommend those items to John. And whatever John has purchased, but Samuel has not purchased, cross recommend those items to Samuel. Why? Because the similarity is very, very high. Now you can't, there is no point recommending, if you want to sell anything to John, look at Samuel's profile and then sell it. Similarly for other people as well. So this is how Jacquard similarity works. This is one of the measures. This is not the only measure. Just as you have Jacquard similarity, you have cosine similarity and other measures of similarity as well. I'm just drawing your attention to one of the similarity based measures. I'm just drawing your attention to one of the similarity measures, which is Jacquard based similarity. So far, is it clear? So far, is it clear? Please ask me questions in case you're not able to understand.
If you can just once again, if you just this similarity procedure which you did and how that the percentage arrived, if you can repeat it, sir.
So firstly, look at the, I'm just going back to the PowerPoint. So this is a very simple way of taking similarity.
Oops.
So this is the data A, B, C, D, and here you have the items. So instead of showing in PowerPoint, let me just take you back to the Excel itself. It will be less confusing. Okay. So you may have any number of products, 10 million products, but just to make you understand, I've just taken the example of 5. But what holds good for 5 also holds good. The mathematical logic is the same, right? So what holds good for 5 should also hold good for 100 or 1000 or 10,000. And here, when you look at the customers here, in this example, we have taken 6. You can have 60,000 customers. It does not, number does not matter. It's the logic which matters. It's like saying, you know, if I see 10 crows which are black, I can extrapolate the same logic saying that all crows are black all around the world, because one bird is sufficient for me to extrapolate it for others. I don't have to go to every crow and check whether it is black, black, black or something like that, right? Take a small sample and extrapolate the logic. So what is the logic here? Let me look at the similarity between two customers. So John has given a rating of 4, 5, 1, so on and so forth. Let me just pick up the example of, let me remove the colors and then show you again. So otherwise it will become confusing. No fill. Okay. So this is what the data set is. So let's begin with the first person. John is the first person. Now I want to recommend something to John. I know his rating. He has given a rating of 4 to product 1. Let's say product 1 is a movie, Sholay, and product 2 is Kahona Pyar Hai. Product 3 could be, you know, I don't know, Dangal. Product 5 could be Brahmastra. Product 5 could be KGF or Pushpa or some movie, right? He has given some rating. Now, next time John comes, I want to make some kind of a recommendation, right? Because unless you make a recommendation, people will not fall for it. Whether it is Netflix or I told you Jabong or Infibeam or Amazon or Flipkart, their business model survives on recommendation. They earn millions and millions of dollars of money purely by recommendation. So you better recommend the right things to the customer. And this is an ongoing process, because there is nothing like, you know, foolproof model, right? The more appropriate the recommendation, the better the chances of the customer buying it. So what should I recommend John? When I look at this John, what should I recommend John? The question is, what should I recommend Samuel? What should I recommend Kiran? What should I recommend Pankaj? What should I recommend Anju? And what should I recommend Ram? I know their rating metrics. This is what is called as the rating metrics, which is the past rating metrics. So let us explore one of the ways, which is a simple measure. There is no hi-fi model, no formula, no equation. It's a very simple, commonsensical approach to recommend something. What the foundational principle of recommendation is, it's a very commonsensical thing that identify the similarity between two people. If two people are very, very similar to each other, very similar, there is a high percentage of similarity between two people, you recommend those items which have been bought by the first person to the second person. And similarly, you recommend those items which have been bought by the second person but not having bought by the first person. Very simple, because we are similar, right? So our tastes and our profiles could be expected to be same, right? As I said, if you and I have gone to the same school, same college, mostly we have done the same course. Let's say we have done PCMB, and then we have done BE, and then basically, we have graduated. By and large, you and I are living in the same locality. Your salary and my salary is the same, so there is so much of similarity. So we are in the same journey, right? If I buy a fridge, maybe you'll also buy a fridge, right? There's a maybe, right? There's nobody can give a guarantee that you will buy. So if I at least find out, so if I have to recommend fridge to somebody, I will recommend fridge to a customer whose profile is the same as another person who has bought the same item. You can say, sir, why should I recommend fridge, why not something else? Commonsensically and logically, you just think, uh, what how do I improve the quality of my recommendation? You can recommend anything, but if we all like to receive recommendations provided it is relevant to us, right? If I am a if I'm a if I'm a die-hard fan of Sylvester Stallone, Bruce Willis, and I'm a or of Bruce Lee, I love action movies, and let's say you start recommending Yash Chopra's romantic movies to me, I may not really like it at all, and maybe even I'll not come back to you again, right? So recommendation should be most appropriate. How do you find out? What should be recommended to a person like me? So this similarity measure, there is a simple formula, right? There is a simple formula to calculate similarity between two users, user one and user two. How do you find out the similarity? It simply says, look at the number of common products that have been purchased divided by total number of products purchased. Right? Common products that have been purchased, right? Now, I've already calculated this, but let me just give you an example between John and Samuel. In the numerator, you have common products. See, this is John. The first customer is John and the second customer is Samuel. Let us first focus on two individuals. Have they purchased product one? Yes or no? Both of them.
Yes, purchase.
So they have purchased. So let me just highlight this, right? In the blue, I'll highlight it. Now look at product two. John has purchased product, sorry, John has not purchased product two, but Samuel has purchased product two. So can this be a common product?
No.
It is not a product, it's not a common product. Now let's look at product three, sorry. Product three, this has been purchased by John as well as by Samuel. So can I call this as a common product?
Yes, definitely.
Yes. Look at product four. Product four is it's a product which has been purchased by John, but it has not been purchased by Samuel. So it's a unique product. So you can't consider it as a unique product. Product five, neither of them have bought product five, because it is neither of them are have any use at all for product five. They have not bought product five. Like this, if you have millions of products, you have to find out which are the common items out of these 5 million products or 1 million products or 10,000 products that your supermarket, that your e-commerce platform offers. Out of these 10,000 products, how many products have been purchased by these two customers? That's the simple logic. So here, when I look at John and Samuel, I'm calculating this again. Similarity between John, comma, Samuel. What is the similarity? You can just say, just put a equal to. Look at the definition, common products. So the number of blue cells, there are two products which have been bought by both of them. So what I'll do is basically, I'll fix the numerator as 2. Now I have to divide by the total number of products, What are the total number of products? Look at this. Let me just count this for you. One. This is, I'll just count it as in red. Correct? Let's look at John first. This is the second product. This is the third product, which at least one of them have purchased or both of them have purchased. 3, I can't count this because I've already included here. Product 5 is a unique product, so I'll just select this. Product 3, I can't count it because he has already been purchased. Rest of the items are basically, not purchased. So look at the red color cells which I've highlighted: 1, 2, 3, and 4. So out of 4 products that have been purchased, 2 products are common between John and Samuel. So total number of products is going in the denominator. Common products are coming in the numerator. So if I just hit a enter and look at percentage here, you can see here the 50% similarity between John and Samuel, right? I'm just giving an example. Let us say just for the sake of argument, just to show you this, how this works. Let us say Samuel has purchased, just for the sake of argument, Samuel has purchased product 4, right? Let us say Samuel has purchased product 4. Then product 4 should also be considered as a common product because both of these guys have purchased this item. Now you can see there are three cells, 3 products are common to both John and Samuel. And since 3 products are common to both John and Samuel, so 3 will go in the numerator. Total number of product, right? 1, 2, 3, 4, 5. No need to count this. No need to count this. So it is 3 divided by 5. Look at this. 60% similarity is there between John and Samuel. All right. Here I know that I'm taking a very small example of 6 people. If you have 60,000 customers, you have to calculate 60,000 values for 59,000 values for John, because you are comparing John with Samuel, John with Kiran, John with Pankaj, John with Anju, John with Ram, so on and so forth. Since you're comparing this, since you're computing the similarity of one person with every other customer, right, you'll get those many values. After John, repeat the same procedure for Samuel. After Samuel, you repeat the same procedure for Kiran. After Kiran, repeat the same procedure for Pankaj. After Pankaj, find out the similarity of Anju with every other customer. After Anju, you go to Ram and find out the similarity of every other individual. So you'll be getting a giant matrix, which will just tell you how similar each of these 2 individuals is. Very simple thumb rule. If the similarity of John is the highest, 50%, 33%, and 40%. Since John has the highest similarity with Samuel, what we are saying is that whatever Samuel has purchased, but John has not purchased, you can cross-recommend, which means just take a look at this 60% similarity. Product 2 has been purchased by Samuel, but not has been purchased by John. So you can recommend product 2 to John. Product 2, correct? Now look at Samuel. Everything that he has purchased, let's say I added this later, let us say this value is not there. I'm just giving an example. This is a common product, right? Product 2 has not been purchased by John. This is again a common product. Last product, John has purchased product 4, but Samuel has not purchased this. So if you want to recommend something to Samuel, please recommend product 4. Why? Because John and Samuel have very, very similar interests. They have similar hobbies and such things. So this is how it works. This is how the similarity matrix works. Is it clear? Not clear?
Clear, sir. It's clear now.
Right. So it is not 100% accurate. Nobody is saying that this recommendation engine is 100% accurate. You can cross question me saying, sir, don't you think it's simplistic? Why have you not considered Samuel's age, sir? Have you considered Samuel's age? Have you considered Samuel's and John's income? Have you considered whether they're married or not? Definitely a person who's married and an unmarried person's behavior will not be the same. Right? Have you considered the locality? Have you considered the degree of education? Boss, I have not considered all those things. Why have you not considered? In an e-commerce place, you will not get such rich data. Right, Samuel and John, nobody will give all this data, right? Many times, if you go to this shopper stop, you literally start fighting with that person, right? He starts many times, especially in some of these websites, they may demand Aadhaar card and such things. Or in general, you may have experience. Sometimes people give Aadhaar card. The moment you give Aadhaar number, everything is open. He can pull out all of the last detail from your this thing Aadhaar card details. So never give Aadhaar card details. We hesitate to give. We are living in a society, in a world wherein people are very, very hesitant to give information about health and such things. So Aadhaar card and all, what is the guarantee that he'll not whack your data? So I mean, I am not even comfortable giving my date of birth. I'm not comfortable giving anything, my address and such things, because it's a problem. So I will do the cluster. So in the end, basically, all your K-means cluster analysis, factor analysis, neural network, all these are wonderful techniques, but they rely on data. In e-commerce space, you will not get much data. You will have data sparsity issue, right? You will have very, very, very limited information. I will not even know your gender many times. I may not even know what is the user's gender, because it may be still simply guest one or guest 008. What is your gender? I don't know. I don't know your age. What is your, which stage of life you are in? I do not know whether you're a college student or whether you're a middle-aged person or you're an old person. I know nothing. So your data itself is very, very sparse. It is very, very poor. Under these circumstances, what can I recommend? That is the question. That it becomes a big question. So you can't go by your regression and cluster analysis. All those are high fundu concepts which rely on data. So you have to make do with what you have available, right? It's like, when I you have to adjust with what you have. So this is where your similarity measures and such things come into picture. Identify who is most similar to which other person. If two individuals are very, very similar, very simple thumb rule, what just cross recommend it to the second person and vice versa. Did you understand this concept, please?
Yes.
Okay, so one question here, why not clustering, correct? So look at this, the answers are there in front of your screen itself. Why not clustering, basically? So firstly, basically, you have sparsity of data and such things. In clustering and such things, you need to have rich data. Amount of here, basically, when you're talking about e-commerce space, you'll have limited data, like, amount of money spent in a transaction. That piece of information I have. The time spent in the time spent time spent. Is this clear? Is it clear? You may have rating. Somebody might have given rating. Number of items he has purchased. Right? You may have this piece of information. A person has come, 9 items he has purchased. He has spent 10,000 rupees. He may have given some rating here and there. Some very brief comment he has given. So when you have infinite number of choices, out of these 3 products, what will you buy? That is the question that we have. You have infinite number of choices. Out of these infinite number of choices, basically, out of these infinite number of choices, if I'm just given 3 variables, with 3 variables, don't expect me to build a cluster analysis model. Is it clear, guys? Cluster analysis requires a lot of useful variables. Those useful variables you don't have. That's the problem. So you can't use sparsity of data is the biggest reason as to why we can't use cluster analysis and such things. If you have so much of data, go ahead and use it. Nobody is stopping you, right? But these simple measures is what we need to use to identify similarity and such things in a e-commerce space. Is this clear, guys? Clear or not clear, guys? The entire
Yes,
concepts
sir,
of
clear.
right, there are a lot of these very there are a lot of these very what shall I say sophisticated algorithms also, right? Nobody is saying that you should not use sophisticated algorithms, all those things. Right? If possible, try to explore these two possibilities. One is what is called as matrix factorization method. Matrix factorization method. One is called as matrix factorization method, and the second one is basically what is called as it's not matrix factorization method. It is what is called as Funk SVD. These are Funk SVD won a award sometime back because it had improved the accuracy in the recommendation engine. You can do a lot of research. You can do a hell lot of research in the world of matrix factor in the world of recommendation engine. So my request to you is, if you are interested in e-commerce and how it works, you can make a you can do some research, a lot of research in e-commerce space itself. So sometime back, I'd done some research on how do you sort of make a prediction. What should I recommend to a person who's a cold start, who's coming to the system for the very first time? First time, if a person is coming, what is it that I need to recommend to him, right? So I don't know what I should recommend to him. So that's right, very difficult, because I don't know any I don't have any information at all about him, right? Not an easy question to answer. So there's a lot of research and such things that are going on in this space. If, as I said, if you're interested, you sort of you can sort of experiment, right? You can just sort of do a lot of research in this. A lot of activities are going on in this e-commerce space and such things. Right. So really read some books or something, and maybe I can just, if you're interested on the, I can just put some pictures exclusively devoted to recommendation engine. Okay, shall I show you how this works in R?
Please, sir.
Okay. So let me just Let me just increase the size. Personally, recommendation engine, neural network. These are the best algorithms. Decision tree also, right? These are my favorite algorithms, right? What do I do? I just want to freeze the screen. We go to window and freeze one screen so that we can just focus on. Okay. The data set that I'll be using for this piece is what is called as recommender lab. Okay. How do I? Just 1 second. Please tell me if you can see the screen. Just one small point I'll just explain.
Yes, yes, we are able to see.
Recommender lab. See, these are the algorithms that you can experiment. Okay, UBCF is one, IBCF is one. Apart from this, SVDs. Uh, SVD is one, which is a very proper one. Association rule-based recommender is another. Popular items is another. Randomly chosen items for comparison is another. Re-recommend liked items is another. Hybrid recommendation is another. Right? Hybrid recommendations is another. Recommender lab. Right, so these are the algorithms that you can use. Recommender lab, you can use any of these things. Train, test, split, you can do. You can do cross validation, repeat it, bootstrap mechanics. There's nothing like R square and such things. Where will you calculate R square? There's no dependent variable at all. So it's not so easy to come up with any model and such things here, because the nature of the system that you're working on is like this. At best, you can calculate what is called as mean square error, right? Some model diagnostics, mean square error, RMSE or mean absolute error. This you can do. Top end recommendation, you can also get precision recall and TPR. So for this, what I'll do is basically I'll use what is called as the movielens.org. Can you see this movielens.org? Because this recommendation engine was initially developed for supporting movie recommendation itself. Okay, just take a look at this top picks. Just read this. Movie Lens helps you find movies you will like. Rate the movies to build a custom taste profile. You have to right. You have to rate it. Then Movie Lens recommends other movies for you. Look at this. This website will itself make a recommendation based on the rating that you have given. Right. So these are all some movies that are there. I will be using the data set from this itself. Okay. So with this, I'll be using this thing itself. So what I'll do is quickly change the screen. Close off this. Let's start with this, guys. Let me begin by loading the package. There is a package here which is called as Library of Recommender Lab. Okay. So the name of the package is what is called as Recommender Lab. We have to use this package, which is called as Recommender Lab. Okay. So is there anything here? It is sort of installed this. Let's just go by data of movie lens. This is the data set which we will be using. Right. So movie lens data set. So people are given a rating. We'll be just using that data set. Let's look at structure of the movie data set. See, this is how he has sort of given the structure, correct? There are two slots here. One is called as data. Within this data, you can see here I. There's a person who has given some rating here, 0, 1, 4, 5, 9. And you have P, right? It's not very easy to understand what kind of data it is this, right? Because he has packaged it in such a way. I'll just show you how we can bring it in a usable format. You also have movies like Toy Story, Golden Eye, so on and so forth, right? These are the movies and this is the rating, right? So the data is not in a proper data frame like structure here, right? What are the slot names we will see? Slot names are more like, in a cupboard, you have slots, correct? In the first slot, what you do is basically you may put all your shirts and such things. In the second slot, you may keep your watches and such things. The same way here, the way he has given the way he has sort of given this data, he has put data, he has also given normalize. These are the two things. Normalize is null, he has not done anything, but data we have. Now we will convert this data set into we will convert this data set into a data frame. Let's just convert this guy into a data frame. Right now it is a lot easier. Look at this user 1. He has seen the movie Toy Story and he has given a rating of 5. The same user has seen Golden Eye. I think these are all kids movie. He has given a rating of 3. He is again 1. He has seen another movie, 4 Rooms, and he has given a rating of 4, so on and so forth, right? So this is basically the data that we have. Let me just clear the screen. Now let me just visualize this data set. It's a relatively large data set. It's not a small data set. So let us just try to get a feel of this particular data set. Now, when you are trying to get a feel of this data set, I'll have to convert this into an image. Are you able to see this image file? Are you able to see this? Are you, are you able to see this, guys? Hello?
Yes, we are able to see. Yeah.
See, we have the users here and we have the items here. Just first 25 rows I'm just showing you, because otherwise the data set will be extremely large. When you see this 25 rows here, you can see here, maybe the first person, you can see a lot of blacks. If it is dark, if it is high rating that he has given, mostly it is black, or else it will be a grayish shade for the lower rating. You can see there are so many white spaces or blank spaces, which means that basically there are many people who have not seen all the movies, correct? If there are 700 movies, I may have seen 25 movies, the balance will be blank. If you take one movie, basically it will not be, not all movies will be rated. Not every user will rate every movie. So this is the reason as to why you will have a lot of data sparsity records. Let us just examine a few records head off. Right? You can see here, this is how the data set looks like. First user, he has rated Toy Story 5, right? 453, right? Again, the same user number one, he is rated GoldenEye. You can see here, this is a lot easier for us to recommend the data now. Check the number of ratings per user. This is histogram. So here, this is the histogram that we have. So you have row count, and this is the column count for movie lengths. So you can see here, there are 400, right? So zero rating seems to be the highest. Not many people have given any rating at all, right? So there are many people, maximum number of movies have not been given any rating. See here, basically the frequency of the movies, almost 200 movies have been given a rating. 200 movies have been rated by around 100 people. But maximum, you see, many movies have not been rated at all. Check the number of ratings per movie. Ratings per movie, right? Per movie, what is the rating? So 100 people may have given a rating here. Let's say 200 people may have given a rating. They have given a rating. This is almost 100, but the frequency of the movies that they have rated is basically 200. It's like that. Average user rating. Let's construct the next diagram for this. Average user rating. On an average, what is the user rating? You can see here on the scale of 1 to 5, people have mostly given 3 or 4. Right? 1, 2, 3, 4, 5. See, 4 people have given a maximum, they've given 4 rating. A lot of 400 people have given a rating of 4. Next is basically 3, which means that they are confined to either 3 or 4. Nobody will give you a very low rating, right? Unless you're to watch a movie, your money is gone, your time is gone. It's such a terrible movie, you can't see it, right? Then basically, let's say like Shamshera, it's a terrible movie. You can't bear it. Some of these movies are like that. Your money is gone, everything is gone. You feel that cheated. Then you will give a low rating, right? Or else extraordinary movie, once in a lifetime you watch some movie which sort of hits the right chord with you, then you may give a rating of 5. Otherwise, people will always give a rating of 3 or 4. So this is the problem when we have such a low. Most of them are giving either 3 or 4. It means that from a statistical perspective or from a data science perspective, we can't analyze this data at all, because there is no differentiation itself. Everybody is giving a average rating. We want some differences, otherwise it becomes very difficult to make some analysis. When you have such a poor rated data, but this is the kind of data that you see in real world also, right? Either people are giving 3 or 4, which is average rating, not very helpful for our analysis purpose. Retrieve the number of users. In this data set, how many users are there? 943 users are there, which basically means that you have a healthy sample size. Not bad at all. We have a healthy sample size. Retrieve the number of movies. Pull out the number of movies. Pull out the number of movies. Control L. Number of movies is how many? So 943, 1664 basically movies have been watched. I hope you're able to understand. 943 people are there, 1443 movies they have been able to rate. Investigate the number of movies rated by the user. When you investigate the number of movies that have been rated by the user, number of movies that have been rated by the user. Look at this. On an average, people have rated 105 movies. Minimum number of, so each user, lowest number of movies that have been rated is 19. So there is one person who has seen 735 movies, right? Maybe a big movie buff. He has rated 735 movies he has rated here. So this gives the distribution of the number of movies that have been rated. Now let's just make a move on. Visualize a part of the data. Let us just visualize not the entire data, but some part of the data. Please let me know if you're able to see this picture.
Yes, sir, it is.
Yes, 25 users, 25 movies. You can see there is so much of sparsity, right? Already we don't have variables. On top of it, we have so much of sparsity and such things. Not a very good sign because there's nothing that will come out of it. You can't expect miracles from this data set because the data itself is inadequate. Let us just check how many movies have been rated, right? How many movies have been rated? Let us just check this. Oh, it's quite a, right? You can see here there's a sea of numbers that we are getting. These are the movies that have been rated, but a bit difficult to sort of control. L I'll do. Okay. Unique vector ratings, let me just see here. 540312. 540312 means basically either they've given a 5 rating, 4 rating, 0 rating, 3, 1, 2. This is a big problem. So what I'll do is basically I'll just check the count of each rating value. Let me just count the are you able to understand this?
Yes, sir, it is
So
zero.
yes, so yeah, biggest is basically 0. Unrated movies are the ones which are 0, which means 14,69,760 cells have not been rated at all. Right? 6,059 cells, not individuals. We are not talking about users here. They have given the rating of 1. 11,000 people have 11,000, not even people, I'm sorry, I'm not saying it right. 11,000 Excel cells. You can just picturize this in terms of Excel cells. 11,307 have given a rating of 2. 27,000 cells have given a rating of 3. 33,000 cells have a rating of 4, and 21,077 have a rating of Fine. Is this clear? So 0 is a big problem here, because if you take the data with 0, your data analysis itself will be distorted, because there is heavy domination of zeros, unrated movies. But that is a tragedy. We don't want 0, right? So this is okay. Table ratings I have anyway done. Let me just plot the same thing and show you. This is how it is. See here, the data is so polarized, right? Everything has come to 0. Able to get this, guys? We have to suppress 0. We have to knock off the 0 and then basically analyze the data. How do we knock off the this thing? How do you knock off the zeros? Because there's a heavy domination of zeros here. So let me just go to the top. I've just cleared the screen. Don't want to take zeros. That's the problem here. Okay. So here, not equal to 0, I'm saying. Vector ratings, but vector ratings must not be equal to 0. Now, let us look at the table of vector ratings. And then basically look at, so this is the numbers that we have. 6,000 cells with 1 rating, 11,000 cells with 2 rating, 27,000 cells with 3. Now, at least this looks better. I would say this looks better. Now, what we can do is we can just do a bar plot as we did before, right? But the object name is table ratings 2. Now you can see here, this is more or less analyzable. You can analyze this data. You can't analyze the previous one because there was heavy domination of 0.
Yes.
All right. By and large, you have an equal distribution. I can't say equal, but it is at least not extreme the way you had earlier. Now comes the algorithm, right? So there is an algorithm which is called as real rating matrix. Right? So recommender registry. Let us just see all the algorithms. I hope you can see this. In R, these many algorithms are there. Let me just show you from the top. Hybrid real rating metrics. But the problem is there is poor documentation, which means that though these engines are there, ALS real rating metrics. ALS is a good algorithm, but they have not explained in detail in R, what are the arguments, how is it better, when to implement. Have they given proper examples? They have not given so many examples. Simply they have given some formula computation at a very high level. They have just made a mention of this. So they have not gone in depth in R, right? So that is one of the problems. So you can use this. You can just experiment with each of these things. Okay, now examine the similarity of a few users. So there are multiple similarity measures. What I showed in Excel was one of the similarity measures, Jacquard similarity. Now, what I will be doing is basically, now you can see here similarity for the first 4 users, right? Earlier I calculated this in Excel. Now I'll be just using it as it is. Using it as it is in the sense, basically I'll let the algorithm compute the similarity and basically look at the method which is called as cosine similarity. You can change it to Jacquard as well, not a problem, right? So similarity between users. So if I calculate the similarity for 943 users, you will get a giant matrix. You'll not be able to use this. You can calculate it and maybe take it later to Excel or use a SQL to highlight which user is most similar to which other user. But here, since I'm only demonstrating, I'll demonstrate for 4 people, right? The principle still holds good. 4 users is what I'm just sort of showing. Are you able to understand this?
Yes.
So what are we getting here?
Sir, this looks like Pearson matrix type, sir.
Yes, yes. Right. So first user, it is finding out the similarity with every other individual. You can see here, when you look at the first 4 individuals, 96% similarity is there with the second user, 83% similarity with the third, 91% similarity with the fourth. I'm just showing only the first 4, but here you can clearly see that first fellow is most similar to second fellow in his purchasing behavior pattern and such things. So if I want to recommend anything to the first fellow, I will look at the behavior of the second fellow, what all items he has purchased, and then recommend something to one. Look at the second fellow, 96.96, 0.92, and 0.93. Highest number is 0.96, which means that to the second fellow, I can recommend what the first fellow has purchased. Look at the third fellow, 83%, 92%, and 91. So 92% is the biggest number. So third fellow and second fellow are quite similar. Fourth fellow is most similar to the second fellow. Are you clear with this?
Yes.
So it is like correlation matrix also.
Yeah, correlation, just that the difference between correlation is that correlation will lie between -1 and +1. Okay, is this understood basically? Right, we have found
Yes,
out
sir.
this. Yes, we have found out the similarity between users. Similarly, basically, I can find out the users' similarity between items here, correct? Which item is most similar to which other item? We can just sort of express this as the similarity. Here you can see a matrix, but for products. The products are Toy Story. These are mostly children movies. So Toy Story is more similar to GoldenEye. If you see a 0.9487, so 94% similarity is there here. So anybody who has watched Toy Story, you can cross recommend GoldenEye because more or less they're similar. So many times you may see here, I had friends who used to watch Yash Chopra's movies because they were big fans of Yash Chopra or Shah Rukh Khan movies, or let's say Amitabh Bachchan's movies. You know, you're a lifelong fan of these people, so you keep watching their movies. Similarly, look at GoldenEye, 0.94, yeah, 94% is the highest similarity. The 0.9429, that is one more. right? So this is how you can construct a similarity matrix and all. Products as well as this. Next is basically we have to create what is called as an evaluation scheme by splitting the data into specific types. We have to create a evaluation scheme, right? So it's our old game wherein we'll be splitting the data into training, test, right? We can just split the data into training data set, test known and test unknown. Training and basically this test known and this is basically test unknown. Training, test known and test unknown. Known cases will obviously you'll have the predictions. For the unknown, you'll not have the predictions. Okay. Now comes whatever we were talking about, user-based recommender model. We'll be building the first model, which is a UBCF model, right? So you can just see a recommender function is used on the training, and we'll be building the first this is the first model that we are building, a recommender on the training data UBCF model. Let us just create the predictions for the test data. Build the model on training, apply it on the test data. That's our old strategy that we have done. Right. Let us just quickly apply the accuracy. Let's just check the accuracy of the model, UBCF model. So it is still running. So this is the prediction. Let us assess the accuracy. So I have to, okay. So prediction underscore UB. Then I have to evaluate the model accuracy. I'm typing the wrong code here because copying becomes a bit difficult, copying the code. So this should give me the accuracy, and this is the as function. Able to understand, we're just assessing the accuracy. Are you able to see this, guys? Are you able to see
Yeah.
this, guys?
Yes, we are able to see. Yeah.
See, we have built the model, we have applied it, we are getting the Ramsey of 1.2. Usually Ramsey should be between 0.5 and between 0.2 and 0.5 for the model to be good. Here it's not a very good model, but it's a decent model, I would say. Mean absolute error should be closer to 0, ideally speaking. Correct. It's we have a high error and such things, but that is expected because the data itself is filled with noise. Is this clear, guys? First model. Okay, let's
Yes.
look at the prediction accuracy and such things, guys. Can you see here NA, which means basically third person, everything is not, we are not able to assess anything, right? So look at the 17th person. He's basically, his predicted value is 4. For Toy Story, he's likely to give a 4, which is on the higher side. So we can recommend Toy Story. 33rd individual, there is nothing NA, because I'm looking at only the first 5 records here, right? 42nd person, either you can recommend Toy Story or GoldenEye. So whichever basically individual has a high rating, you can sort of give that kind of a recommendation. Is it clear? Now what we can do is basically we have built a UBCF model. Now IBCF model will also be the same here. Okay. UBCF model is one thing, IBCF model is another thing. Recommender training data set. I'm just changing the argument as IBCF, item based collaborative model. It is still running, as you can see, so I'm just waiting for it to finish. UBCF model, IBCF model. It's still running, guys. IBCF may be slightly on the slower side.
It is. I think it's working. It's slow bit.
It is slow, and item-based collaborative filtering may be taking some time.
Okay. Okay.
But I hope you got a picture about UBCF. All that we are doing is feeding the training data set and changing the argument here to IBCF, item-based collaborative filtering. I think it might take some time.
Um, can I ask a query, sir?
Please, please, please. In the meanwhile, you can ask query.
So this IBCF, that is item-based collaborative filtering, is also one of the segmentation techniques, na?
IBCF, it's not a segmentation technique, madam.
Okay, how you like it is a recommender system, like you are well, I actually joined late, so here item based collaborative filter, so it will be um, the matrix you had created earlier, like the John and Samuel. Was it IBCF?
No, when I say John and such things, John and Samuel, because there are two users. We are finding the similarity between two users. That is user-based collaborative filtering, not item-based.
Okay, so we use the products common, so it was user behavior. Which products the user selected, yes. So commonality, similarity between them, and this is I product based.
Exactly. If you're finding out the similarity between two products, it is IBCF, item-based collaborative filtering. On the other hand, if you're finding out the similarity between two users, the way I showed John, whatever it is, then it is called as
Yes.
user-based collaborative filtering.
So, so these algorithms just applying on your data will make
Yes.
are actually making the work easy.
Yes.
Not,
Yes.
not
Yes. I don't have to manually calculate this. One more thing is that, madam, here when you're developing any software, it is always best to try with either a priori algorithm or this, because if an algorithm works on this, it means that the software is quite robust in terms of speed and such things. Because you can see here
yeah,
it has to do so much of computation at the back end, unless
yeah.
it is so fast. You'll not be able to get the accuracy and all.
So
It will
it
take a
is
long time.
predicting right now. Right now it is predicting, calculating the predictions.
Exactly.
Yes.
Yes.
Okay. So you have so at the back end all these things are being calculated to get the final result.
Yes.
So is it the script that is for IBCF you have written for training
Yes.
and testing data?
Yes, madam. Yes, madam. So I'll just show you the result of movies one. So first movie, if you see here, madam, it is most similar. First movie, it is most similar to these movies: Angels and Insects, Pillow Book, Eve's Bayou, Good Will Hunting, Secret of Roan, Ainesh. These are the movies which it is similar to. Top 10 is basically what we are seeing here. Which are the top 10 movies which it is most similar to, and this is what we are getting.
Yes, sir.
Okay, I
So
hope this is.
generally, the K-means algorithm that we studied in the last sessions,
Yes, madam.
there we were identifying the similarities between the different data items. So how you differentiate between those algorithms where we were also using similarity between either the k-means was also used to cluster the similar things, and here somehow again we are finding the similarity pattern between either the products or the users. So how they
Yes.
are different?
Madam, usually in the case of K-means cluster analysis and all, I told you, we have rich customer data, right? You will have, it is mostly used for offline retail and such places. Wherein if you're going to a big bazaar, you're going to a big, let's say, store and such things, you'll give the data of what is your age, number of transaction, amount of money spent, which all products you have purchased. All those data will be there, and based on this basically segmentation is done. There in the case of k-means cluster analysis, you have customer data, product data, demographic details and such things. You may have 50-60 different variables. Here this algorithm which I am showing is exclusively tailor made for online customers, wherein the data is very very weak and poor. I do not have 50-60 variables. At best I may have items bought, how much money has he spent, and user rating I may have in the case of movies or books. Based on limited data, I'm trying to find out the similarity. That's the main difference, madam. So these algorithms and such things are used only for e-commerce data, not for other data.
Okay, great, sir. Because it is very important for us to understand that which algorithm should be suitable in which scenario. So you rightly explained, and I could justify myself also that this whatever you have explained today. So I think you use the term the scarcity, and the data is not spreaded equally. So in this case, we can use these algorithms that you have used today. Yeah. Thank you,
Definitely,
sir.
madam. No problem, madam. Any questions, please?
And sir, kindly share the scripts of this, and this will be actually a great help to if we want
Definitely,
to
madam.
try these things.
I will definitely share, madam. I'll definitely share. But are you able to understand what we did, everybody? You get a feel of it? Where to use, where not to use this?
Yes, sir, definitely.
Any questions? Any other questions? Okay, guys, we have covered recommendation engine. So if I'll just quickly summarize, we began with linear regression, then we moved to logistic regression. I think I've already given you my this thing. Let me just also type my number here. Okay. Linear, logistic, neural network. Then we moved to decision tree. Then we looked at a priori algorithm, and this is the next item in the list. We are discussing recommendation engine. So the last 6 days was, I had a good time with you. Thank you so much. I hope it was mutually beneficial to everybody. If you have any questions and such things, please ask me. It will be of great help.
Yes, sir. So finally, sir, this is the sixth day, and we had a wonderful session with Mithun sir, and we had a lot of learning, starting from the scratch of artificial intelligence to going to the deep learning and the neural network. So that was a really very it's a good learning out of the way that yesterday whatever we have seen. So, sir, a big thanks to you, and we wish that you'll keep guiding and working in the similar way and helping the education community. So, on behalf of all my attendees and from on behalf of the my Bharati Vidyapeeth deemed to be university and Institute of Management and Entrepreneurship Development. Also on behalf of AICT Atal Academy Training and Learning Academy, we are thankful to you, sir, for being with us for 6 days. We learned a lot, and we look forward the similar sessions in future too. Thanks a lot, Mithun sir, and we'll be in touch. You are in the group, and we'll certainly would like to invite you again and again, sir. So we are still having 5 more days, and we'll be updating you on the how this FDP is progressing. Thank you so much, sir. Thanks a lot. Friends, yeah, Mithun sir, yeah. So thank you so much. If you want to say anything, you can. Yeah.
I just want to thank you for the opportunity, and also thanks to all the participants for patiently listening. I know it's after a heavy, long day's work from 7 to 9. To listen in a monologue will be difficult. I'll anyway share all the scripts and such things. All the best to everybody. Thank you so much, sir, once again.
Thank you so much. Thank you so much. Thank you so much.
Thanks. Bye.
Yeah, thanks a lot, sir. Bye bye. Yeah. So Sonal, please take it ahead and kindly formally introduce Prashant Rajouri Guruji, who is the IIT Mumbai alumnus and a senior faculty with Art of Living.
Yes, sure, sir. So I would now like to take the privilege to introduce Mr. Prashant Rajour. He's a graduate from Chemical Engineering from the Indian Institute of Technology, Bombay. He has been closely associated with His Holiness Sri Sri Ravi Shankar for over 25 years. A senior faculty of the Art of Living, he conducts courses on yoga and meditation, which have been attended by thousands. People from the remotest area to the biggest corporations have experienced peace, joy, and healing throughout his programs. Throughout his association with the Art of Living organization, he has been responsible for the initiation and management of innumerable service projects, which include free schools for children, rural development, women empowerment, and relief and rehabilitation programs for various disaster victims in India. He has also participated and deliberated at international conferences and seminars covering various topics such as renewable energy, child and women welfare, and social development. We are glad that you could join us today, sir. So over to you now.
Welcome, Guruji. I'll request all of you to please open your cameras and yes, have a conversation with the Guruji. Participants, yes, you can. Yeah, if you're in position, you can open it. And so, Guruji, kindly take it ahead. Yes.
Yes. However you are, it's okay.
Yes, sir. It's nice to see you after a year.
Yeah, it
Yes,
is nice to be back. Fortunately, I am also from Pune, and I have been coming to the Bharati Vidyapeeth campus in Pune for more than 30 years. Even before I went to IIT, I have been coming to the campus there.
Great, sir. That's nice, sir.
Yeah. So in our life, art of living is all about life, right?
Correct.
In our life, we are all striving to be successful. And we all think, success is some black box somewhere, which we are all trying to decipher. And today, in this short talk, we will, put it in bullet points, like an algorithm. We were talking about algorithms in bullet points. What do we need to do to become successful? So success has two parts. One is skills, and the other is energy. Now, if you see any cricketer or any footballer, musician, they have skills, but just having skills is not enough. Energy is also required, right? To be successful, to be a good sportsman, to be a good professor, to be a good student or entrepreneur, we require energy.
True,
And
true.
if we see skills also can be divided into two parts. Sorry, I've lost my electricity, but I think you're able to hear me, no? Dr. Shah?
Yes, sir. We are able to hear you, sir. We are able to hear you.
Just give me a minute.
Yes, sir. Yes, sir.
Okay, the light is back also.
Yes, sir. Yeah. Correct.
So if you see, the skills can also be divided into two parts. One is the professional skills and the other is the personal skills. Professional skills was what you were learning just when I joined, all the algorithms and how to develop it further. All these trainings and faculty development program is to develop the professional skills. But if we see, after a point of time, just having professional skills is not enough. We require some personal skills also. Now, in an organization, all types of people are there, and there are so many people who are good in their field, but they're not very good leaders. They are not able to extract work out of other people, isn't it? Why? Because the personal skills are lacking. So what is personal skills? Dr. Shan, we are able to hear me, no?
Yes, sir. Yes, sir. We are able to hear you. Yeah, yeah, yeah. We are. Yes, you're audible.
Yeah, I am audible. Okay.
Yeah.
So let us understand what personal skills is all about. Okay. Now, uh, you know, we have been in administrative positions, leadership positions for a long time. There are certain people who listen to us. And sometimes, no matter what, even we might be the boss, the people just refuse to listen to us, isn't it? So what is lacking there is that personal connect with that person. Okay, and that is what is that personal skills. Many times professional skills are of no use. Actually, it is the personal skills which is driving the professional skills. It is more powerful. That is why people who are not academically so good are also very good leaders. Why? Because that personal connect is there. They are able to get out the best from the people around them. And to be successful in life, we need that personal skills. So personal skills means what? I will share a story. Okay. Would you like to listen to a story? See, it is night time. We have our brain is bombarded with so many intellectual stuff. So this is more for relaxation. Okay. This session is more for relaxation. So there was this man who was walking on the streets in Bombay, Pune. We are all familiar with that. And all around, there are blackboards there. No? The mandals are there, and the mandals have blackboards. One such blackboard was there, and on that blackboard was written, "The person who reads this sentence is a fool." And a friend reads that sentence, and he becomes very upset, very agitated. What is this? How dare the person who has written this make a fool out of me? I don't know him. He does not know me. How can he make a fool out of me? I'm going to teach him a lesson. Until that time, I'm not going to move away from this place. So he stands there. 5 minutes pass, 10 minutes pass. After 15 minutes, he has an idea. You know what he does? He rubs out whatever was written on the blackboard and then writes, "The person who has written this sentence is a fool." So this is what happens to us, no? We want to correct somebody, and we go to correct also, but after some time, we realize that the way we corrected that person was not the right way. We regret, maybe after 2 days, maybe after 2 months, right? And many times we need to correct ourselves. If we see probability, 50% is our mistake and 50% is somebody else's mistake in a relation, right? If the relation is not good. Okay, so we would like to listen to one more story. So there was this elderly gentleman who thought his wife was turning deaf. So he went to a doctor and said, "Doctor, my wife is turning deaf and I don't want her to know. So please suggest a way so that I can deal with her and she does not know that she's turning deaf." So the doctor says, "Very good. When you go home, you ask a question to your wife. If she responds, good. If she doesn't respond, move a few feet closer and repeat the question. And you keep on repeating this process till the time she responds. Then you know at what distance you need to communicate with her." So he opens the door of his house, asks the question, "What are you cooking for dinner tonight?" Hmm. So no answer. Little few feet closer again, "What are you cooking for dinner tonight?" And this process continues till he's only 5 or 6 feet away from his wife and again asks, "What are you cooking for dinner tonight?" His wife, in a very angry tone, she responds, "For the 11th time, I'm telling you, I am cooking dal and rice tonight." So, the many times we think the problem is with someone else, but the problem may be with us. So we need to learn to correct ourselves and learn to correct others. See, as I said, probability is 50-50, but 70% of the situations can be corrected if we can correct ourselves. Okay. And that is what soft skills is all about. Learning to correct ourselves, learning to correct others in such a way that we create a win-win situation. Usually it is me winning over the other's point of view and somebody else winning over my point of view, isn't it? But can we create a win-win situation where the other's point of view is also taken care of and my point of view is taken care of, and we create a win-win situation? That is what soft skills is all about. It is not easy. It is not easy, but can we maximize it? We learn about maximization and algorithms also and other things also, but can we maximize that win-win percentage of win-win situation? That is what soft skills is all about. And a support to that professional skills, soft skills, is our energy levels. Only when we have energy, whatever skills we have can become successful. Now, if there is a weak person, very weak and meek person, and you ask him to move a 100-kilo stone, he will struggle to move that 100-kilo stone, right? And at the same time, if we ask a bodybuilder, 150-kilo bodybuilder to move that 100-kilo stone, he will do it easily. Why? Because the energy levels are there. To be successful in life, we require those energy levels also. So professional skills, we have been this, and I am not an expert in whatever professionally you are learning, but the other two I can help you, and both go hand in hand. When the energy levels are there, we become our personal skills improve, and when our personal skills improve, our energy levels also improve.
True.
So that is a synergetic effect. One helps the other. So it's whatever starting point. So there's not much time today, but
Yes.
what we do is we will do a little exercise, which will, we will ourselves experience that, how our energy level, just suddenly the tiredness will go away. We will start feeling fresh. So 3-4 minutes, 5 minutes, we'll do that. Okay.
Okay. Yes.
So let us close our eyes and just sit very easily and comfortably. Hmm. It's the end of the day, the last activity of the day. Some
Yes.
of us have not had dinner, so we'll have dinner and go to sleep. So with that thing, let us sit easily, comfortably, and close our eyes. Okay, just relax, close our eyes. And with a big smile, let us take a normal deep breath in. With a bigger smile, deep breath out. Again, with a big smile, breathe in. And breathe a bigger smile, slowly breathe out. Let us continue doing this. Breathe in and out as slowly as possible and have a big smile, as big as possible. And let us keep our eyes closed. Big smile, slow breath in and slow breath out as slowly as possible. Let us not forget to breathe in and out as slowly as possible with a big smile, very big smile. With every breath, the smile is becoming bigger and bigger. And as the smile becomes bigger, the breath is becoming slower and slower. And relax. Let us keep our eyes closed. Breathe normally. Let us keep our eyes closed. Relax the body. Relax the mind. Let the thoughts come, whatever thoughts are coming. Just relax. We are not making any efforts for anything in our life for the next 2-3 minutes. We are just being with whatever is happening in our body, in our mind. If sleep is coming, let it come. Again, let us take a deep breath in and breathe out. Again, take a deep breath in and breathe out. Let us become aware of our body and surroundings. And taking our own time, very slowly, we may open our eyes. How was it?
Totally relaxed.
Good?
Very good,
That's
very
one.
good. Yes. Yeah. Yes. Others, how? Yeah.
Others can write it in the chat box. I can read it.
Yes. Totally relaxed, Guruji. Yes.
See, when we are relaxed, we will be able to do more work. If we can learn techniques, this also we can practice. Breathe in and out with a big smile few times a day. Whenever we feel tired, we will feel relaxed, we will feel calmer, and then we will be able to work more. So when energy levels are high, our soft skills also improve. That is a time we get less angry, no? That is a time more happy.
Very true. Very
Good.
true.
That is what art of living is all about. If you have any questions, we can just put it in the chat box. 1 or 2 questions we can take, and then we'll end. I don't want to keep you long because it's quite late in the night.
Yeah, yeah. S- So, any questions from anyone? Please write on the chat box, or you can ask directly. Rabin sir.
No, sir, I don't have any questions, sir.
Okay, okay, okay. Baljit ma'am.
Thank you, sir. It has been a nice experience.
Yes.
So
Really nice, because it is very required.
Dr. Kamal Alaskar is asking, how can you control your anger?
Yes.
If I give you any solution right now, it is going to be of no use. You know why? Because when anger comes, no, we don't remember anything. So then you will get more angry. Oh, I did not remember he had given such a simple solution and I don't remember. So the indirect way is we increase our energy levels. When the energy levels are high, no, we are not affected by situations. why we are getting angry? Because we are being affected by situations, isn't it? And if a person is strong, see, a person has strong immunity. When the person has strong immunity, diseases don't affect that person, right? So in the same way, we need to have a strong mental immunity, so that situations don't affect us. Okay, and to develop that strong mental immunity, we require higher energy levels. So this technique which we have learned, 3, 4, 5 minutes we practice every day, practice 3, 4 times a day. It will take time. And then some exercises like this. Would you like to know the source of anger? We can just see, open a jaw a little bit, and at the joint of the jaws here, we can press. We can press here at the joint of the jaws. At the joint, some of us are pressing in the cheeks, not in the cheeks, not behind, at the joint. See here, it is midway between the ear and the edge of the lips. So if you open a mouth, we press there, we will feel some pain there. See, are you feeling some pain? That pain is the source of anger. So let us gently massage that. Gently massage that. It will take time to get rid of that pain. It's not going to go so soon. So this is one exercise also that will help us reduce anger. And the second exercise is massaging the lower jaw like this. And the third exercise is moving the jaw from side to side like this. And fourth exercise is opening the mouth like this. Okay, so 4 exercises. Exercises I have given you, but you have to practice it. It's not, anger is something which does not go in 2 months or 1 year, 2 years. Over a period of time, it reduces. So, and little bit anger is good. It's necessary. Okay, if you don't get angry, people around us will take us for granted. Okay, so just to keep people around us on their toes, sometimes we need to get angry, but it should be like salt in the food. Little salt in the food makes the food tasty. If you have too much salt, then it spoils the food, and no salt also will spoil the food. So just like a pinch of salt, that much anger we should have. Okay. Good.
Yes.
So it was nice spending some time with you after a year. Next time, let's see, if I had a little advance notice, no, I could have come to Pune. I was planning to be in Pune today, but
Okay. Yeah.
15 days
Even
ago, I
next
decided. Yeah.
even
So
next week we are this will continue. If any by any chance if you're coming, please let us know.
this week, next week, no chance. I'm
Okay.
going to
Okay.
North India on Tuesday night. I'm
Okay.
going to North.
Okay.
My original plan was to come to Pune for 2-3 days and then go to North India, but
Okay.
the which I had in Pune was not enough, so it's okay.
Right. Guruji, I have a question. Like many times we find that many of us remain in stress without any reasons. Okay. So how to handle this work stress and also tips for that.
That is what I have answered. No, see,
Mhm, mhm,
be successful, we require skills and this. So
mhm.
why do we get stress? Is because we don't have enough skills or we don't have enough energy,
Okay.
isn't it? So skills again might be professional skills, it might be personal skills, and lack of energy. That is what is creating stress.
True.
Okay. So that is, success and stress go hand in hand. If you are
Mhm.
able to manage stress, we are successful. If you're not able to manage the stress, then the success also doesn't come.
Okay. Okay. So we have to balance that. Yes.
Yeah, professional skills we are improving. No, so
Uh-huh.
many times we don't have the knowledge to how to professionally approach it. But then sometimes professional skills are also there, but we are not able to get the team to work together. So personal skills are required, energy levels are required. All that helps us manage stress.
Right.
And I teach many techniques. This is what, half an hour I can't teach many things. So
Yes.
many things are.
Uh,
Uh,
Anyone ask anything? If you have any questions, you can ask to Guruji. I think it's very short time, so like it takes some time to opening up and the.
No, it's okay, and it's quite late in the.
Correct, and the weekends and yeah, so that is the.
Yeah, so good. Enjoy yourself. All the
Yeah,
best. Hope you
yeah,
success
yeah.
FDP.
Correct. So while living, just like before sleeping, can you tell some exercise like which we should do it, and so that we get the nice sleep?
Nice sleep, no?
Yeah.
One very simple exercise I will tell you. When we lie down, we breathe in through the nose
Okay.
and we breathe out through the mouth like this, as if we are blowing through a straw. Breathe in through the nose and breathe out through the mouth, as if we are blowing through the straw. So 10-15 breath we do. And then once we are able to do this, another step we have to take in this is that in breath has to be slightly shorter than the out breath. So if the in breath is about 2.5 seconds, out breath should be 3.5 seconds, slightly shorter. Okay.
Okay.
We do this exercise before sleeping. In 2-3 days, maybe at the most 1 week, we will start getting very good sleep.
So in breath should be shorter or out breath should be shorter. That is.
The out breath should be longer.
That should be longer. Okay.
Out breath should be longer, and breathe in through the nose, breathe out through the mouth.
Yes. That's nice. I think that will certainly help us to get a very nice sleep.
Good, people need to rest also.
Rest, yeah. So thanks a lot, Guruji. And on behalf of Bharati Vidyapeeth deemed university, and also on behalf of our Institute of Management and Entrepreneurship Development, and also on behalf of AICT, the Atal Training and Learning Academy, and on behalf of all our faculties and participants, a very big and very warm thanks to you, sir, and for joining us for a short time and guiding us and giving us the tools for the stress and the smile. So that has been wonderful. We look forward to meet you in some other FDPs and in some other programs. Thanks a lot for being with us. Thank you so much, sir. I think your blessings will take us. It will be great success for our FDP next week. Thanks a lot, sir.
All the best. All the best, and you have a good learning experience.
Yes, sir. Thanks a lot. Thank you, sir. Thank you.
Good night. Thank you.
Bye. Thanks, sir. Yeah. So I'll request all the participants to please mark their attendance before leaving. And now it comes to the end of the day of the 6th day of online this thing, the online FDP. We look forward to meet you on Monday, that is 9:30. We are planning to start. So, like, if you, all of you, if you please come join us 9 o'clock for the breakfast, so we'll be able to start the program. So, once again, thanks a lot for all of you, and a great thanks to all volunteers, those who helped us, and they will be with us for the physical also. So and to all faculty members, those who are there and they have taken out the time. Thank you so much, everyone. Looking forward to see you on Monday.
Thank you so much, sir.
Yes,
Thank you.
ma'am. Thanks a lot, ma'am. Thanks.
Thank you.
Bye bye.
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 Thank you, sir. Thank you.
Thanks a lot, sir. Thanks.
Good night, sir.